Welcome to this explainer. Today, we're tackling a massive issue, the AI cost crisis. You know, generative AI is absolutely incredible, but right now, it's pushing enterprise cloud expenses into completely unsustainable territory. But don't worry, because today we are mapping out the exact step-by-step strategic architecture blueprint you need to actually decrease your token expenditure by up to 70%. Let's dive right in.
So imagine this. A massive global logistics giant sets aside an entire annualized budget for a brand new enterprise AI development assistant. They think they're set for the year, but then they burn through the whole thing in just 4 months. 4 months! A budget meant to last 12 months just completely evaporated by April. How does something like that even happen? Well, I'm going to let that question hang in the air for a second. This absolute financial disaster was driven by a fundamental misunderstanding of how modern AI pricing actually works under the hood. But stick with me to the end of this explainer because I promise to reveal the exact mathematical secret and the structural blueprint that would have completely prevented this mess.
To really get to the root of this problem, we have to look at the massive shift in how software is billed these days. For years, right, we've been totally conditioned by the traditional software as a service, or SaaS model. It's comfortable, it's predictable. You pay a flat per-user fee, and boom, you know exactly what your operational expense will be at the end of the month. But state-of-the-art large language models, they throw that entirely out the window. Modern AI is built on raw, variable volume. We're talking specifically about context and generation token counts. It's essentially like a digital utility meter that just spins faster and faster the more complex your prompts get. And honestly, this sheer volatility is catching even the most highly experienced infrastructure planners completely off guard.
And the reason this token billing is so relentless? Well, that starts right at the very top of the supply chain. Take a look at this staggering number, $660 billion to $690 billion. That is the projected annual capital expenditure, or CapEx, by the world's top 5 hyperscale infrastructure providers. They are undergoing this monumental shift in resources to build out hyper-specialized data centers. They're deploying insanely expensive liquid cooling systems and buying up massive amounts of high-density silicon accelerators. Now, this kind of massive capital intensity doesn't just vanish into thin air. It filters directly down to the enterprise customer. You and I are paying for those liquid-cooled data centers through premium, consumption-based pricing models that are specifically designed to rapidly amortize those huge infrastructure costs. And it's exactly this premium pricing environment that breeds a highly expensive developer behavior. It's a little something called tokenmaxxing. Tokenmaxxing is what happens when developers and internal business units are just left entirely unmanaged. They'll take massive, completely unstructured legal documents and code repositories and just shove them into a prompt window just to execute a really trivial extraction task. They are essentially throwing massive context windows at incredibly simple problems. And the result? You get these massive linear spikes in cost without any corresponding increase in the actual usefulness of the output. I mean, think about it. You're basically paying to process an entire encyclopedia just to find a single sentence over and over again.
Which leads us to what is perhaps the single most dangerous financial trap of all, the Agentic cost multiplier effect. See, we are migrating away from standard human-guided single-turn requests, where you ask one question and get one predictable answer. Instead, we're moving toward autonomous multi-agent workflows. In these new frameworks, software agents break down tasks, they evaluate intermediate code, they inspect their own outputs, and they self-correct through iterative reasoning. Now, don't get me wrong, it is a massive leap in capability, but it's also a totally dangerous paradigm shift for corporate budgets. Statistical monitoring shows that executing a multi-step business process via an autonomous agentic system requires anywhere from 5 to 30 times more input and output tokens compared to a simple single-turn request. And what if an agent hits an edge case error state and just loops unconstrained? No way around it, a single user request can execute hundreds of background calls within seconds, spinning that utility meter completely out of control.
Okay, before we solve this crisis and I reveal the exact architecture blueprint that can actually slash these costs by 70%, I want to take a quick second to ask for a little favor. We are on a mission right now to reach our goal of 1,000 subscribers. So if you are finding this breakdown helpful so far, please hit that subscribe button right now. It really is the best way to support the show and ensure we can keep bringing you these deep dive explainers. We absolutely love breaking down these complex topics for focused learners like you. So hit subscribe and let's get right back to the solution.
All right, so we've diagnosed the disease. Now it's time for the cure. The blueprint, a tiered multi-model architecture. Let's look at how completely abandoning the monolithic single model approach changes absolutely everything.
Here is your strategic architecture blueprint. It's actually pretty brilliant. We divide the workload into 3 distinct tiers. Tier 1 utilizes local small language models, or SLMs. We're talking 1 to 8 billion parameters here, things like Llama 3 8B or 5.3. These are perfect for real-time classification, high-volume data parsing, form extraction, and local autocomplete. And the financial logic here, it's an extremely low cost per token and literally 0 external API fees if you self-host them. Plus, it really minimizes data leakage. Then you step up to Tier 2. This is your balanced medium-cost commercial models like GPT-4o Mini or Claude Haiku. These handle multi-turn customer care agents, text summarization, and drafting. They offer incredibly optimized pricing curves and high agility at just a fraction of a cent per 1,000 tokens. And finally, we have Tier 3, the frontier high-reasoning flagship engines like Claude Sonnet or GPT-4o. These are your heavy lifters. You use these for core system architecture generation or really complex algorithmic synthesis. They have a premium cost structure, right? So they must be retained strictly for nonlinear, high-stakes logic execution under strict guardrails. The whole idea is to match task complexity with the leanest possible processing node.
So the truly crucial point here is the operational math behind this routing layer. And actually, this brings us right back to our logistics giant from the beginning of the explainer. Remember how they blew their entire annual budget in just 4 months? Well, they were likely pushing 100% of their volume straight through a premium Tier 3 frontier model, just burning money. But by shifting 80% of baseline corporate utility tasks away from those premium endpoints and instead routing them down to optimized Tier 2 and Tier 1 instances, the weighted average unit price of token ingest drops non-linearly. You are addressing the cost issues directly at the API layer. If that logistics company had just utilized this 80-20 multi-model split, their budget wouldn't have just survived the year, they would have built a highly cost-efficient AI platform with funds left over to preserve those heavy reasoning budgets for truly deep, complex analytical challenges.
But listen, architecture alone isn't quite enough. You also need hard programmatic constraints at the deployment phase. Let's rapid fire through 3 pragmatic tactics for token optimization. First up, structural context caching. System prompts and permanent documentation, they should be completely frozen using system-level caching. You basically compile the main rules once, so you aren't paying massive full ingest token penalties on every single multi-turn conversation. Huge money saver. Second, deterministic code fallbacks. Please, do not use large language models for basic arithmetic or simple string transformations. It's total overkill. Integrate deterministic programming code blocks right ahead of the LLM to filter out those basic tasks. Save the expensive generative models purely for actual semantic reasoning. And third, rigorous token budget limits. Every single API key must feature hard, automated limits on maximum generation lengths along with sliding transaction caps. Because if an agent starts looping, system circuit breakers must terminate it immediately before real money is burned.
Which really leaves us with this final, absolutely critical question to consider. Is your current AI architecture building a competitive advantage, or is it just bleeding money? Because managing the rising costs of AI is not about telling your teams to stop using AI. It's definitely not about reducing overall adoption. It is entirely about refining the underlying technical structure. You have to transition away from the centralized model, adopt this tiered multi-model infrastructure, and finally take control of your tokenomics. Thank you so much for joining me for this explainer. I really hope this blueprint helps you build a scalable, highly cost-efficient platform for the future. Keep learning, keep optimizing, and I'll see you in the next one.